So in basic calculus, we have a standard result in limits that if limit x tends to a f of x is equal to 0, then limit x tends to a f of x power f of x is 1. So by the time I write this, limit x tends to a f of x power f of x is 1, and I am giving you this limit x tends to a f of x is equal to 0. Some of you may have an idea that since this f of x is tending to 0, when this x is tending to a, 0 power 0 is equal to 1. But this is not the case actually, because 0 power 0 is an indeterminate form of powers and its value is indefinite actually. So now let us try to solve this question. Let me try to show you how this result is valid. Now it's given limit x tends to a f of x is equal to 0. Correct? Now if you see carefully, we are going for the value of limit x tends to a f of x power f of x. Let y is equal to f of x power f of x. So let us try to apply logarithm on both sides of this equation. Log y to the base e is equal to log f of x power f of x to the base e. And of course, when there is a logarithm of which is of the form log x power n to the base ea, this n which is on the top can be written as multiplication ahead of this logarithm. And if we do that, log y to the base e is equal to f of x into log f of x to the base e. Now let us try to apply limit on both sides of the equation. Limit x tends to a log y to the base e is equal to limit x tends to a log f of x to the base e into f of x, or f of x into log f of x to the base e, doesn't matter. So now this implies, see here, whenever this limit x tends to a f of x is tending to 0, then definitely this portion of f of x will give you 0. And what about this portion of the function? Now see here, whenever this f of x is getting to 0 and this base is e, which is basically more than 1, you know the value of e is 2.718, which is more than 1. So log f graph looks something like this. Log f of x to the base a when a is greater than 1. Correct? So this value when x is tending to 0, of course on positive side, is minus infinity. So this value turns out to be minus infinity and this value turns out to be 0. So this is of the form infinity into 0. So we don't have any standard analysis to continue here. So we'll try to rewrite this function which is on the right hand side to a particular fashion. Like limit x tends to a log y to the base e is equal to, look, this is minus infinity. So in order that if I want to make this as plus infinity, what could I do? Let us write a minus multiplication in and out of the limit. So minus log f of x to the base e into f of x. Now this is of the form 0 and this is infinity. So now let us try to analyze the case. What do we have on the left hand side? Limit x tends to a log y to the base e is equal to, now see here, minus, this is of the form infinity now and this is of the form 0. So if I make a little adjustment, can I write this f of x which is in the numerator here as 1 by f of x in the denominator, like limit x tends to a log f of x minus log f of x to the base e divided by limit x tends to a 1 by f of x, because both are equally same. So this implies limit x tends to a log y to the base e is equal to, now if you see, this value turns to be infinity and this value again turns to be infinity. Correct? So we have infinity by infinity form. Of course this minus sign still sustains here. So this is equal to minus. Now this is of infinity by infinity form, so we can apply L'Hospital's rule. If you apply L'Hospital rule, we have limit x tends to a minus log of f of x is 1 by f of x into f dash of x divided by, this is 1 by f of x, so the differentiation of 1 by f of x is minus 1 by f of x whole square into, since there is f of x here, the inner derivative is f dash of x. So let us cancel these two and let us cancel this minus signs which are here, and let us also cancel this f of x and this square. And you know, limit and log are interchangeable functions. Since both are mathematical operators, we can interchange them. So we have log of limit x tends to a y is equal to, what do we have? This minus sign is here. This only f of x that is in the denominator is left with us. So that can be written as limit x tends to a f of x. And what's the value of this limit x tends to f of x from our basic analysis? 0. So this is equal to 0. So if this is equal to 0, if you know log of limit x tends to a y is equal to 0, then you know, of course, this is to the base e. Let us write this, which we have written here. So log e of something, log of something to the base e is equal to 0. So this implies the index that we have here is limit x tends to a y is equal to 1. So, and what is y basically? F of x power f of x. So if limit x tends to a f of x is 0, then we attain limit x tends to a y, where y is f of x power f of x is equal to 1. Okay, so this is the analysis why this identity is getting satisfied, but not because of this particular reason. Okay, stay tuned, we'll look at other. So now that we have seen this result is getting valid, so based on this result there came some questions in GATE. For example, let us try to look at some previous GATE questions that occurred. First question is something like this: limit x tends to 0 x power x, and what's the value of this? As per this analysis, this is 1. 2. Limit x tends to 0 sin x power sin x, which is again 1, because x is tending to 0, the sin x tends to 0. Similarly for tan x, limit x tends to 0 tan x power tan x is equal to 1. Similarly, limit x tends to pi by 2 cos x per cos x, this is also equal to 1. Okay, so they came questions like this. All these are actually previous GATE questions that came. So if you know this particular formulation, we can answer all these questions within single second just by looking at this analysis. Thank you all. Okay, so if you see this question, they are asking for the mean value c when we evaluate the value c using mean value theorem for this function within this interval range. Now if you look, they didn't mention which mean value theorem to use. We have basically 3 mean value theorems, like Rolle's mean value theorem, Lagrange's mean value theorem, and Cauchy's mean value theorem. But if you see, this Rolle's mean value theorem is a special case of Lagrange's mean value theorem when f of a is equal to f of b. Now since there is only one function got involved, we will use by default Lagrange's mean value theorem. Okay, so let us try to use this. So if you solve this question, try to solve this. Now what is this f of x? E power x into sin x minus cos x. Okay, now if the limits are a to b, what does Lagrange's mean value theorem tells us? F dash of c is equal to f of b minus f of a divided by b minus a, when we are talking about this particular function in the limits of a to b. Okay, now if you see, what's the value of b here? 5 pi by 4, and what's the value of a here? Pi by 4. So if you compare these things, what is f of pi by 4? E power pi by 4 into sin pi by 4 minus cos pi by 4. And if you see one thing, you may feel like by using your calculator, you're gonna evaluate this e power pi by 4 value and sin power pi by 4 and cos power pi by 4. But if you see, this sin pi by 4 is numerically equal to cos pi by 4, which means these two are numerically same. So the answer is 0, because 0 into some positive quantity is 0. Similarly, if you talk about f of 5 pi by 4, what does it have? E power 5 pi by 4 into sin 5 pi by 4 minus cos 5 pi by 4. And if you see again, sin 5 pi by 4 and cos 5 pi by 4 both are same. So this is also 0. This is 0 because if you see this sin of 5 pi by 4, this 5 pi by 4 falls in third quadrant where sin is negative, and the value of sin 5 pi by 4 is minus 1 by root 2. Similarly, the value of cos 5 pi by 4 is also minus 1 by root 2. So this both values are numerically same, so this gets cancelled and we will have f of 5 pi by 4 is equal to 0. So if you substitute here f of b, where b is 5 pi by 4 and a is pi by 4, then this implies f dash of c is equal to 0, because this f of b and f of a both are same. F of 5 pi by 4 is also 0 and f of 5 pi by 4 is also 0. So what is f dash of c from the given function? What is f dash of x? If you try to write f dash of x from this function, what we have? This is one function and this is second function. So if you apply the product rule, e power x first function into differentiation of second function, which is cos x minus sin x plus second function sin x minus cos x into e power x. So this implies this f dash of x is equal to, if you see, if you take e power x common, you have cos x plus sin x minus cos x. So this cos x gets cancelled. So this is 2 e power x into sin x. So therefore this is f dash of x. So what is f dash of c? 2 e power c into sin c. And for evaluating the value of c, we got this f dash of c is 0. This statement here, correct? So this implies 2 e power c into sin c is equal to 0. But if you observe one thing, this e power c is a non-zero for any finite value of c, correct? So what's the other thing that should be 0? Sin c is equal to 0, which means c is equal to 0, comma, plus or minus pi, comma, plus or minus 2 pi, all these things. But if you see, now you may feel one thing, as soon as you go till this step, you will see sin c is equal to 0, which means you may feel that c is equal to 0 satisfies this equation, and you may go for option A, but that is wrong. And that's why 0 is also given as first option here. But the actual answer is, when you are defining this mean value theorem, you state that this c, what you are talking about, this c should lie within this interval, correct? Because when defining the mean value theorems, you say that c belongs to a comma b, correct? So which means this c should lie within this a comma b interval. So if you check out the values of sin c is equal to 0 for the value of c, this c is equal to pi is the correct option, which is lying in between this interval and also satisfying this equation. So the answer is pi but not 0. Okay, please take care of this location of point C. Thank you all. So if you look at here, this is one more question that came in GATE. So the question is like this: the maximum value of e power sin x divided by e power cos x. So if this is a given function, we need to find the maximum value of this particular combination. So let us try to solve that. Let y is equal to e power sin x divided by e power cos x. Okay, so now directly you know one thing, that if there is any function f of x and if you want to find the maximum value or minimum value of this function, the first step is you will differentiate this function with respect to x and equate it to 0. But here if you directly apply such condition, it's a bit difficult to differentiate these kind of functions. So let us write to some formation that this is sin x minus cos x, because e is just a numerical constant and e power something divided by e power another function is nothing but a power m minus n format. Basically, if you try to look, this is the form. Now if you see, the value of e as we discussed is 2.71 and this value of e is more than 1, which means if you want to find the maximum of this complete function, which is same as this, it's enough if you find the maximum value of sin x minus cos x, correct? So let f of x is equal to sin x minus cos x. Now your main intention is to find the maximum value of this particular function, knowing so that we can determine the maximum of this particular complete function. So let us apply our standard analysis for this function f of x. So for finding maximum, what we do, we'll differentiate this function and equate it to 0. So if you differentiate this, differentiation of sin x is cos x minus differentiation of cos x is minus sin x, and which is equal to 0, correct? Because as per Euler's theorem, what do we say? If you have extreme at any point, definitely that at that point derivative should be equal to 0. So cos x plus sin x is equal to 0, which implies this cos x is equal to minus sin x, and which implies tan x is equal to minus 1. So this implies x is equal to 3 pi by 4, because basically it is pi minus pi by 4. Now see here, x is equal to 3 by 4 is in the second quadrant, and normally if this is the only stationary point that is obtained, we need to check for the second derivative test. Means basically you need to find f double dash of x and you need to substitute this point. Let us suppose this is x naught, and you need to check this functional value at x is equal to x naught, correct? So at x is equal to x naught, if this particular value is less than 0, then we say this function f of x, which we are talking here, has maximum at this x is equal to x naught, correct? But since this is a numerical answer type question and definitely he is asking for the maximum, he is telling us indirectly that there is a maximum value for this function, and we have only one stationary point. So let us assume that this particular value is giving maximum. So what is f of this function? F of 3 pi by 4 sin 3 pi by 4 minus cos 3 pi by 4. And if you see, this is sin pi minus pi by 4, which is again same as sin pi by 4, minus this is again cos pi minus pi by 4, which is minus cos pi by 4. So this is 1 by root 2 plus again value of cos pi by 4 is 1 by root 2. So the total answer is root 2, because 2 by root 2 gives you root 2, which means maximum of f of x is equal to, therefore maximum of f of x is equal to root 2, which means the maximum value of this sin x minus cos x is root 2, which means this implies maximum value of y is equal to e power f of x, where you are treating this f of x as sin x minus cos x, is equal to e power root 2. So this e power root 2 is the answer for this question. Now if you know one extra point, one point in excess, that could help you much better in this case. For example, if you have a function like this, the range of, if your function is like a sin x plus b cos x plus c, if this is the function that you have, then the range of this function is c minus root of a square plus b square, comma c plus root of a square plus b square. Means this is the maximum value of this function and this is the minimum value of this function. Now if you want to find maximum of sin x minus cos x, what if you compare this a sin x plus b cos x plus c is equal to sin x minus cos x, what are the values of a, b, c that you have? A is equal to 1, b is equal to minus 1, c is equal to 0, correct? Now we want the maximum value of this function sin x minus cos x, and you know the maximum value of this particular function is c plus root of a square plus b square. So if you substitute, maximum of sin x minus cos x is equal to c, which is 0, plus root of a square, which is 1 square, plus b square is minus 1 whole square, which is root 2. So if you know this particular analysis, then instead of doing complete differentiation and all, you can directly get the value of, which is maximum of this sin x minus cos x. So you can directly put e power root 2 here itself, which will be same as this quantity. Understood? So this is one short way that you could answer this question, which actually came in GATE. Thank you all. So today we will see how to evaluate such kind of integrals. Okay, so which is, there's a function of f of x on this side, and down there's f of x plus some function, and this function has a specific format. We'll see how to solve. Solution. If you see, integral a to b f of x dx can be written as integral a to b f of, in place of x we can substitute a plus b minus x, and if you see, the result doesn't change for this kind of integral, even if you substitute x as a plus b minus x. So if you apply this particular format to here, let I is equal to integral 0 to pi by 2 square root of tan x by root of tan x plus square root of cot x dx. Now if you apply this above formulation for this kind of integral, then this is equal to integral 0 to pi by 2 square root of tan of 0 plus pi by 2 minus x divided by square root of tan of 0 plus pi by 2 minus x plus square root of cot of 0 plus pi by 2 minus x dx. Now if you see, this is tan pi by 2 minus x, which is cot x, and similarly here this is cot x and this is tan x. So this is equal to integral 0 to pi by 2 square root of cot x divided by square root of tan x plus square root of cot x dx, or this is square root of cot x and that is square root of tan x. So these are interchangeable. Now for example, let this is I and I am calling this equation as 1. If you see this thing, this implies I is equal to integral 0 to pi by 2 root of cot x divided by root of tan x plus square root of cot x dx, and let us call this equation as equation number 2. Now suppose if you add both these equations, therefore 1 plus 2 gives you, see, both are equal to I, so I plus I is 2I, and this 2I is equal to integral 0 to pi by 2 square root of tan x divided by square root of tan x plus square root of cot x dx plus integral 0 to pi by 2 square root of cot x divided by square root of tan x plus square root of cot x dx. So if you see, the limits of integration for these two integrals is same. So this implies 2I is equal to integral 0 to pi by 2. Now if you see, if I write these two integrals under same integration sign, this denominator is constant. So I am taking the denominator common, so tan x plus root of cot x dx, and now if I add the numerators, I will be having root of tan x plus root of cot x dx. And if you see, both numerator and denominator are same, so I can cancel them, and this value is equal to 1. So 2I is equal to integral 0 to pi by 2 1 dx, which is when you integrate 1 with respect to x, you have x when limits are changing from 0 to pi by 2. So this implies this 2I is equal to, when you substitute the upper limit here, this is pi by 2 minus, when you substitute the lower limit here, this is 0. So this implies I is equal to pi by 4. And what is I from our initial approximation here? So this implies integral 0 to pi by 2 square root of tan x divided by root of tan x plus square root of cot x dx is equal to pi by 4. So this is the required outcome of this integral, and the value of this integral I is equal to pi by 4. Thank you all. So now that we have seen the integral 0 to pi by 2 square root of tan x divided by square root of tan x plus square root of cot x is pi by 4. But you have seen the process is a bit long. So for these kind of questions, we can visualize something. Look, for these kind of questions, the integral a to b f of x divided by f of x plus f of a plus b minus x dx. If there is any integral of this kind, the answer of this integral is b minus a by 2. So this is some short thing that you can visualize. Now see, for example, if you look at this example, if my f of x is, let f of x is square root of tan x, then what is f of a plus b minus x? We have seen before also, tan of 0 plus pi by 2 minus x, correct? So this is nothing but square root of cot x. So which means this particular integral is falling under this category. So just by looking at the answer, you can write the answer of this integral is b minus a by 2. Here a is 0 and b is pi by 2. So if you substitute that, pi by 2 minus 0 divided by 2, which is pi by 4. So like this, in a short way you can write it. In this one special case is if a is equal to 0. If a is equal to 0, then integral 0 to b f of x divided by f of x plus f of a plus b minus x dx is equal to, when a is 0 here, this formula becomes b by 2 directly. So when you see such kind of integrals here, when there is 0 here, answer is simply half of this upper limit. If you see, this is pi by 4, which is half of this pi by 2. Okay. Similarly, some questions come in GATE also. Like for example, this is one such kind of question. Second question is like something like this: root x divided by root x plus square root of 5 minus x dx. Some more times they'll ask you integral 0 to pi by 2, like basic trigonometry involving trigonometry, sin x by sin x plus cos x dx. Questions of this kind. So for this thing, what's the answer for this now? B minus a by 2. So 3 minus 2 divided by 2, which is 1 by 2 is the answer for this. Similarly for this, what is the answer? Since this is 0, half of this upper limit integral, half of this upper limit. So half of this upper limit is pi by 4. So in this way you can answer such kind of integrals when integral is falling under this particular category, which is the denominator is a summation of the function itself plus f of a plus b minus x for given limits of a and b. Thank you. So this is one question that came in GATE in previous years. So the question is like, the length of the curve y is equal to 2 by 3 into x power 3 by 2 between x is equal to 0 and x is equal to 1. Actually, if the curves are of different geometry, you can directly measure the length. But for curves such, which is like in this case, we have some different technique by which we will find the length of the curve. Because if the curve is irregular, we can't directly measure the length. Okay. So let us try to see. Let me show you some analysis before going for this straight away. Now let us suppose this is the curve y is equal to f of x. Okay. And basically, of course, this is 0, x, and this is y axis. Now suppose if I want to measure this part of length dl, for example. Now see here, let me enlarge this particular dl something like this, dl dx, and this is dy. And of course let us assume my choice of this dx is so small that this curve which is here can be approximated as a straight line. In that case, this we can apply Pythagoras theorem, and we have dl square is equal to dx whole square plus dy whole square. And this implies, what is the expression for dl that you have? Square root of dx whole square plus dy whole square, okay, under root, okay. So now if you take dx whole square common here, you will be having dx whole square of 1 plus dy whole square divided by dx whole square, which we can write as dy by dx whole square, okay. And now this dx square, if I bring out of the integration, I have dl is equal to dx into root of 1 plus dy by dx whole square, correct. So this is how we will evaluate the expression for the small change in dl. Now if you want the complete length between any two points, x is equal to a and x is equal to b, for example, then what you should do for getting this L, total L is equal to integration of this expression, which is basically root of 1 plus dy by dx whole square into dx, and we need to integrate this function between the limits a to b if you want the length between x is equal to a and x is equal to b. So this is the basic formula to evaluate length of any curve between any two points, but of course this function should be differentiable because we need to substitute dy by dx obviously. So this is the function in which it was asked. So let us try to find the answer for this question now. What is given? Y is equal to 2 by 3 into x power 3 by 2. So what is dy by dx for this question? 2 by 3 into differentiation of x power 3 by 2 is 3 by 2 into x power 3 by 2 minus 1, which is actually 1 by 2. So this 2 3 gets cancelled, which means dy by dx is equal to square root of x. This is what we have. So if you substitute in this formula for finding the length of this curve between x is equal to 0 and x is equal to 1, we have L is equal to integral 0 to 1, because we are integrating in between x is equal to 0 to x is equal to 1 into root of 1, integration of 0 to 1 of 1 plus dy by dx whole square, which is root x whole square dx, which is basically L is equal to integral 0 to 1 root of 1 plus root x whole square is just x dx. Now can I write this as integral 0 to 1 plus x whole power 1 by 2 dx, which is equal to 1 plus x whole power 3 by 2 divided by 3 by 2 within the limits 0 to 1, correct, because integration of this is a power n is a power n plus 1 divided by n plus 1, and since this is the inner derivative which is having 1, so L is equal to this 2 by 3 into, because this 1 by 3 by 2 can be written as 2 by 3 into, if I substitute 1 here, 1 plus 1, 2 power 3 by 2 minus, if you substitute 0 here, this is 1 power 3 by 2, which is basically 1. So L is equal to 2 by 3 into this 2 power 3 by 2 is nothing but 2 into root 2, correct. So 2 into root 2 value is, root 2 is 1.414, so 2 into 1.414 is 2.828 minus 1. So L is equal to 2 by 3 into, this is 1.828. So if you go for 3 table, this 3 table cancels this 7.609, let us round off to 2 decimals, so 0.609 what we have. So L is equal to 2 into 0.609, which is 2 9s are 18, 1, 2 6s are 12 again, so 1.218. So if you round off to 2 decimals, this answer is around 1.22. So 1.22 is the length of the curve. Y is equal to 2 by 3 into x power 3 by 2 between x is equal to 0 and x is equal to 1. You can mention the word units here, of course, always. Okay, so please make a note of this. Thank you all. So if you see, there came one more question. The value of integration 0 to 8 and integral y by 4 to 2 x into dx dy is dash. This is basically one double integral which we could solve. So let us try to solve this question. Let I is equal to integral 0 to 8 integral y by 4 to 2 x into dx dy. Correct. So now if you see, what is the first variable of integration? X. And what is the second variable of integration? Y. So if the first variable of integration is x, the limits on the first integration is, or the first integral is limits of x. Similarly, these are the limits of y. Y is equal to 8. Now let us try to plot this first. Okay. If you try to plot the curves that are given here, what are the curves we have? Y is equal to 0, y is equal to 8, x is equal to y by 4, and x is equal to 2. Okay. So let us try to observe all these equations. First of all, this is x-axis for which the equation is y is equal to 0. This is y-axis for which the equation is x is equal to 0. So now if you plot these curves here, equation y is equal to 0 is already plotted, which is x-axis. Next, y is equal to 8 may look something like this. Y is equal to 8. Correct? Because the lines y is equal to constants are parallel to x-axis. What is the next equation? X is equal to 4y, which is same as y is equal to 4x. So the line y is equal to 4x passes through origin, something like this. Y is equal to 4x. Now what is the last limit that we have? X is equal to 2. Look here, if this point, if you try to write the coordinates, y value is 8. So what is x value? Since this point is lying on the line y is equal to 4x, if y is equal to 8, x will become 2. So the line x is equal to 2 may look something like this. Correct? Now out of these two regions, actually have two bounded regions here. Correct? Now out of these two regions, which is the actual region that is representing our limits of integration. Now if you see this particular line, x is equal to 0, y-axis, this equation x is equal to 0 is not in these constraints that we are dealing with. Correct? These are the set of constraints which are given by the integration, but this line x is equal to 0 is not present here, which means this line is not actually a limit of integration here. Correct? So if you erase this is the required region. Correct? Now if you evaluate this integral, I is equal to integral 0 to 8. Look, we are integrating x with respect to x, so the integration of x with respect to x is x square by 2 within the limits of an integral as y by 4 to 2 and this whole dx, dy. Correct? So this implies I is equal to integral 0 to 8. Look, when you substitute 2 here, this let us take this 1 by 2 common out. So if you bring this 2 out, we have x square. So if you put 2 here, 2 square is 4. Minus, if you put y here, y by 4 here, we have y square by 16 to this whole dy. Correct? Which is equal to half into integral 0 to 8, 4 minus y square by 16 dy. Now this is single variable integration, which is normal to us. So if you do integration with respect to y, integration of 4 is 4y minus integration of y square is y cube by 3, and of course this 3 when multiplied with the 16 we have 48 within the limits 0 to 8. So this is equal to 1 by 2 into, look, if you substitute upper limit 4 8s are 32 minus, if you substitute 8, 64 into 8. This is what we have divided by 48 is the total numerical value that we attain. Now if you simplify this 8 cancels this 48 6 times because 6 8s are 48, and this 6 within 2 table will cancel this 3 times, and this is 32. So this is equal to 1 by 2 into 32 minus 32 by 3, which is 2 times 32 by 3 as a whole. So if you cancel this 2 and 2, we have 32 by 3 as the answer for this question. Correct? So this is how you will be evaluating this integral using technique of double integration. But now if you have little idea physically what these quantities are representing, you can attain the answer this 32 by 3 in further simple analysis. Look, if you remember, many of you might have covered engineering mechanics course in basic undergrad. So what does it say? Integral x dA divided by integral dA is equal to x bar, which is actually the x coordinate of the centroid that you are dealing with. Correct? So which means integral x dA is equal to x bar into integral dA is nothing but area bounded by this constraints which we have. So here if you see, this dA is nothing but dx dy or dy dx depending on the limits that we write. So integration of x into dA physically represents area bounded by these 4 curves, which is basically the area of this triangle, into x coordinate of the centroid of this figure. So x bar into area. So now if you see this correctly, this area is the area bounded by these 4 curves which are given here, basically the limits of the integration, and x bar is the x coordinate of the centroid of that particular region. And if you see, if I triangle, the centroid is at a distance x by 3 if this coordinate is x comma 0. Of course, for a right angle triangle case at least. Correct? So if you see for this triangle, what is the area of this triangle? Half into base into height, and this is a right angle triangle, so this base is 2, and what about height? Height is 8 units into what is the centroid that we have? See, this total length is 2, so the centroid is at distance 2 by 3 of this 2 units. So 2 times of 2 by 3, because it is at 2/3 length of this total. So 2 gets cancelled. We have 4 into 8, 32 by 3. So this is how you can evaluate the value of this integral if you have certain geometrical sense. Thank you all. So this is one question that came in GATE again. So the question is like basically change of order of integration. What is this change of order of integration? We will look today. So by changing the order of integration, this double integral which is of this form has got transformed to this form. Then in that case they are asking what's the value of this q basically, and it's given q is of some specific format. He is asking for this constant k. Okay. So now let us try to analyze this question. Solution. What is given integral? This. So let I is equal to integral 0 to 8 integral x by 4 to 2 f of x comma y dy dx. Correct? So now if you want to change the order of integration, some of the students generally they have misconceptions, like they'll take these limits on integration and they'll interchange these limits, like they'll put x by 4 2 here and 0 and 8 here, which is actually a wrong inception. Okay. Second way of getting a wrong answer is they'll interchange these two limits and also they interchange this dx and dy, which is also wrong, because these limits keep changing if you change the order of integration. And how do they change? We'll look in today. Look, see here. Suppose if the first integrating variable is y, which means the limits on this first integral are limits of y. Correct? And these y limits are in forms of x. And similarly, when the second integrating variable is x, you know these limits are x limits. X is equal to 0 and x is equal to 8. So now in this integration we have 4 limits totally. What are they? X is equal to 0, x is equal to 8, y is equal to x by 4 and y is equal to 2. Now let us try to plot this 4 equations. What are the 4 equations? If you could retest them. X is equal to 0, x is equal to 8, y is equal to 2 and y is equal to x by 4 and y is equal to 2. So these are the 4 equations that are available with us. So let us try to plot these 4 equations first. First of all, x is equal to 0 is nothing but y axis, which is x is equal to 0, which is already plotted. X is equal to 8, and you know lines of the form x is equal to constant are parallel to y axis. So let us suppose this is the line which is x is equal to 8. Okay. Next, y is equal to x by 4. This is of the form y is equal to 1 by 4 into x basically, which passes through origin. So if you try to draw, of course this line has a positive slope because 1 by 4 is positive. The line looks something like this. Correct? And the equation of line is y is equal to x by 4. And what's the next thing you have? Y is equal to 2. Now where does this line y is equal to 2 comes here? See here. What about this point? Suppose if I want to plot the coordinates of this point, x value is 8, and if you put x is equal to 8 here, you have y value is equal to 2. Correct? Which means the line y is equal to 2 may pass something like this along this point. Y is equal to 2. Correct? So let us draw a straight line for this as well. So if this is the case, now we have 2 regions. Let us suppose this is first and this is second. Now out of these 2 regions, which is the actual region that we should consider? See here. If you look at this line which is at the bottom, this line is x-axis basically. And what's the equation of x-axis? Y is equal to 0. So which is not present here actually, which means this line is not actually a constraint for our integration. So which means this region is infinite, but this is the enclosed region which is bounded by all these curves. So now if you are changing the order of integration, look, how does the limits change? Double integration f of x comma y, and of course if here first variable of integration is y, and when we are interchanging, then first variable of integration is x, which means the limits on this particular integral should be limits of x, and those x limits should be in terms of functions of y. Similarly here these limits should be limits of y. Correct? So let us consider a horizontal strip here. Okay, So if you consider this horizontal strip, why do I consider horizontal strip? Because I have x as my first variable of integration. Suppose if I have y as my first variable of integration, I would have considered vertical strip. Okay. So now see carefully. What is the limit that is bounding this strip? X is equal to 0. Correct. On the right hand side, if y is equal to x by 4, what is the value of x? X is equal to 4y, which is same as y is equal to x by 4, which means these two equations, x is equal to 0 and x is equal to 4y, are founding a boundaries for this strip. So basically your x changes from x is equal to 0 to x is equal to 4y, means 0 comma 4y are the limits of this integration. If you look at this particular moment, the answer for this question is already attained, because he is given this integration when it is interchanged. I mean, if the variables of integration are interchanged, this is q. Correct, and it's given q is of the form ky and this is of the form 4y. So basically the value of k is 4. You can answer at this moment. But for the completeness, if you solve this question, what are the limits of y? This point is 0 comma 0 and what is this point? 8 comma 2. So y is changing from a maximum, from a minimum of y is equal to 0 at this point to a maximum of y is equal to 2. Understood? Which means this integral basically gets converted to this, where we have p, q, r s values as 0, 4y, 0 and 2. If you generally summarize the result, f of x comma y dy dx with limits in the given question x by 4, 2, 0 and 8. This is 0 actually. 0 and 8 is same as double integral f of x comma y, changing the order of integration dx dy, and if you interchange the limits, we have 0, 4y and what do we have? 0 and 2. So this complete limits gets changed. Okay, it's not like interchanging the limits of these two integrals or interchanging this x and y here. Okay, so this is how you'll change the order of integration in general cases, by considering the curves that are bounding the regions actually. Okay, so thank you.